Like it could just be x, or it could just be a. Like I said, it could be a number. It could be 1, 2, 3, 4. Or it could be kind of a combination of those. Remember we had like 2x? That's a variable and a number kind of combined. So it could be a product of a number and a variable. A product and a number of a variable. So some examples of this. 2. 2 is a monomial. It's just a number. It's just one thing. We could have x. X is just one thing. But like I said, we can have multiples of things. We could have 3x is a monomial. We can actually combine two variables. We could have something like xy, or what'd you say?
YB.
Yeah, YB. We could have a YB. I just chose XY because that's in my notes. We could have X, Y, and Z. We could have a number in front of that. We could have like a 14 X, Y, and Z. All of those are monomials. When it becomes not a monomial is when you put an addition sign between it or a subtraction sign, because then you have two monomials being combined. But these are all examples of monomials. Well, a monomial with the same variable and exponents, those are going to be, we've already done this, these are your like terms. Those are those terms you can actually add together. Those are your like terms. And we can combine like terms, right?
Yes.
Make sure you get your phone up. Okay, we are now adding and subtracting monomials, but we already did that. We did that. That was combining like terms. We're just changing kind of our terminology that we're using. We are switching to calling it adding and subtracting monomials. Well, when we're adding or subtracting monomials, we combine like terms. So to add or subtract monomials, we're going to combine like terms. Yeah. All right. So if we have 4x plus 5x, what can I simplify that to? 9x. Yeah. They're common like. We can combine our like terms. Do they both have the same variable after it? Yeah. So 4x plus 5x should just be 9x. It's going to get harder, though. It's going to get harder because we're going to talk about multiplying. That's where it gets difficult. That's where we have to remember rules. All right, if I have negative 12ab, this is where we're stepping up a little bit from what we just did. Do you see how this ends in ab and this ends in ab? That means they're still like terms. If the variables match, they are considered like terms. Yeah. We would have negative 14ab. Perfect, because we're going to do this negative 12 minus 2, which gives that negative 14 that you had. I could do the work off to the side if you want to see it. So negative 12 minus 2 is negative 14. So we are going to have negative 14ab would be our correct answer if I asked you to simplify that. M squared and m squared, are those the exact same? Yes, they're called like terms. So if you have like terms, you're just adding the numbers in front of it. So I have 7 minus 9. Now, if I'm in the 7, positive 7, and I walk myself back 9 steps, we should be at negative 2m. Negative 2m, and then we will attach the squared. Perfect. It's got to remain, right? we're not finding the product. When we find the product, it's going to be different. So when we're adding or subtracting, our terms stay the same. We just ask ourselves, is it a like term? If it is, we combine it. If they're not, we don't combine it. So we leave this as negative 2m squared. Just like Campbell said, we're not multiplying. It's not a product. When it becomes a product, it will change a little bit. All right, our next one. I need to get rid of the parenthesis first, right?
Yes.
And we learned that rule called distributive property, where we have to distribute what's in front of it to everything in there. We have to distribute this negative to what's inside of here. It should become a positive 8 because a negative times a negative gives me a positive. So we have negative 8k plus 8k.
16k.
Ooh, careful.
Oh, just k. 0.
Careful.
Oh, wait. 0.
Careful. I hear 1. I hear negative 16. Negative 0.
Wait. Yeah, 0k. There is a negative 0.
There is no negative 0. It's either 0 or it's not.
It's 0k.
It's going to be 0 k's or just 0. It cannot be just k because that means you have 1k. So if we have negative 8 plus 8, it's 0, which means you have 0 k's, or we just have 0. Do not put k down for this one because that would imply you have 1k. We would have just 1k, Kyra. We'd have 1k if I did something like 8k minus 7k. That would equal 1k or just k. Do you see the difference? So if it cancels out, it's just 0. All right, we don't have time to go through all of these, so let's try to pick one of the more difficult ones. Let's skip down to maybe
10.
We'll skip down to 11.
16.
We'll skip down to 11. We'll try a couple of these. Okay, we're going to do 11. Now, we want to do 11 because do you see this k squared? Is k squared the same thing as k?
No.
No, so that means it's not a like term with the k. Is there another k squared though?
Yes.
Yeah, right there. These will be like terms. I have a k squared and a k squared, so I have 12 plus 7,
19.
which should be 19.
K squared.
19k squared. Perfect.
19.
All right, then my next one is I do have these k's, right? I do have two k's that can be combined. I have 4k minus a k. What happens if I have 4 k's and someone takes one of my k's away?
3k.
I only have 3 k's left, so that's going to be a 3k.
Also, 19k squared plus 3k.
Yes.
Yep. Does that make sense?
Yeah, that's what I
Yeah.
Okay, let's diagonally go to number 14. Let's do number 14 together.
Whoa.
Just remember, we don't say easy.
Ah, got it.
If we got it, awesome. But it's not easy until we all master it. Okay, Gabby, you going to be okay? Okay. Do you need to go somewhere? Okay. Can you keep your head up, please? Thank you. All right. Now, this is where this steps up a little bit. Do you see this a squared b squared? Do we see another one that has a squared b squared? Okay. So, do you see the one with the 3 attached to it? Are you sure it's not the same? Don't we have an a squared b squared? It's the same. Now, what number is actually in front of this? There's a 1 in front of there. There is a 1 in front of here. So we have 1a squared b squared plus 3a squared b squared. So we're going to have 4a squared b squared. So do you see this 1 here? And we have the 3 there. We just have to do the 3 plus the 1 will give me my 4a squared b squared. And then we have, notice how we have 2 ABs. So we have to do the numbers in front of it. Let's go sit in that pot over there. We can't seem to be able to function. Okay, so if I have a 9AB and a negative 12AB, we're going to do 9 plus a negative 12 or a negative. What was that? 9 minus 12. Well, which one's bigger? Is the 9 or the 12 bigger? 12. So we should end up with a negative number, right?
Yes.
And how far away is 9 from 12? 3. So it'd be a negative 3. It'd be a negative 3AB. Good with that? Okay, then we're going to get to the more difficult stuff because this is just combining like terms. We've already combined like terms. The only thing we expanded to is now anything that comes after that number has to match anything else we're combining it with. So we had to combine a squared b squared with another a squared b squared. We had to combine ab's with ab's. That's the only step we took forward with adding and subtracting. So that shouldn't be the big thing of today. The big thing for today, and this is why I'm kind of skipping around, is I want to get to multiplying monomials. When you multiply monomials, can you not sit there either? You sure? Okay. All right. So to multiply monomials, you don't need to have like terms. That only works for adding and subtracting. Like terms only work for adding or subtracting. So we don't care about like terms. What we do care about is our base number. Your bases must be the same to do this multiplication. So notice how these both bases are x's. I can multiply both of these. And when you multiply with like bases, like x to the a times x to the b, we're going to write this as x to the a plus b.
That makes sense.
When you multiply, you're actually adding your exponents. So when we multiply, we don't care about like terms. We just care about the base of it. What was that?
Oh, no.
Okay. Yeah. All right, and you need a calculator too, don't you?
Yeah. I don't know where my TX started at.
Okay, so let's put this to use. All right, so we're going to do 4 cubed times 4 to the 8th. And we're going to simplify it first. We're supposed to find each product and we're express our final answer using only positive exponents. So let's see how that works. So we have 4 to the 3rd times 4 to the 8th. Now, if we look at our rule, we have the same bases, so I can turn this to 4 to the 3 plus 8, which is the same thing as 4 to the 11th. So 4 to the 3rd times 4 to the 8th, we have to know how to rewrite that as 4 to the 11th. Do not plug this whole thing in your calculator because I'm going to ask you on the test to write each step. I need to see that you know that this is 4 to the 11th. Now we can type it in our calculator. Now we can go, what's 4 to the 11th? And let's type it in our calculator. Remember we used that little caret button, that little one that looks like a little arrow?
419.
Say that one more time.
490,000.
I'm just going to take
It's 4,194,000.
It's 4,194,304 is the correct answer for that.
That's a huge number.
It is a huge number. So we end up with 4,194,304.
Yeah.
Okay. Yes. We're going to do number 18 first, because number 18 is an important thing for using our calculator. Now, notice how these both have the same bases and they're -7, right? So they have the same bases, so when I multiply it, I add my exponents. So this is going to be -7 to the 4 plus 5, which is 9. It's 4 plus 5 gives me that 9. So remember, when we are multiplying, we are adding our exponents together to make a new exponent. Now, when you type in your calculator, you need to use parentheses. You need to open a parenthesis, type in -7, close a parenthesis, and raise it to the 9th power, because this better come out as a negative answer. You do, because if you raise it to the 8th, your calculator will make it positive. We have to get used to putting parentheses around it. I don't have time to teach you how to use a calculator. You got to bring your own. All right, so we should have ended up with negative 40,353,607.
But you have to write like the exact number.
You have to write the exact number.
Oh, so we can't write like 4.1 and like
Nope. You have to write the exact answer. Do not shortcut it. Do not just say it's about negative 40 million. Okay, our next one says 2 to the negative 6 times 2 squared. They have the same base, so we can do this multiplication. We could turn this to 2 to the... Yep, because it'd be negative 6 plus 2. Be careful on your negatives. That is negative 6 plus 2, so that gives you to the negative 4. So this is 2 to the negative 4th. Now, we got to remember something. It says I don't want any negative exponents. So let's remind us how to deal with negative exponents. To make it positive, we
make it a fraction.
We make it a fraction. So we're going to have 1 over 2 to the 4th. And remember, it can be easy when I'm doing it. It's much harder when you have to remember all these rules on your own, right? You're going to have to memorize all of these particular rules. So our end answer is going to be 1 over 2 to the 4th, which is 2 times 2, which is 4, times 2 is 8, which is 16. Yeah. Yes. Because it says you need to find the product, express your final answer using only positive exponents. So we have to understand if I have a negative exponent, I must put it as a positive exponent by turning it into a fraction. Okay? And then I think someone asked for number 20, right? Now here's the thing. Here's what makes 20 a difficult problem. We have 15 times 15 to the 6th, right? We have a hidden exponent there. We actually have 15 to the 1st. 15 to the 1st is 15. You have a hidden 1 all the time around things. So don't look at that as being 15 times 15 to the 6th. Look at it as being 15 to the 1st times 15 to the 6th. That means, what's 1 plus 6? 7. So we're going to have 15 to the 7th. And real quick, just to push through, because I want to get to all this stuff, we're going to have 170,859,375. It's a big number.
I wish I had that much money.
All right, I'm going to go down to the variable bases. Because hopefully we can have some time to practice on our own and get to the more complicated stuff. When you have variable bases, we do the exact same thing we did with our numbers, but we can't plug it in our calculator. So we have x squared times x to the 5th. We're going to have x to the 2 plus 5. So this way, we can't rely on our calculator for this one. It'll be x to the 7th. X to the 7th. We can't use our calculator for this one, so you better know the rules that this is x to the 7th. For our next one, we have m to the negative 1st times m to the 3rd, or m cubed. If we add those together, we'll have m to the negative 1st plus 3. Well, negative 1 plus 3 should just be 2. We should have m squared.
Would this one be K0?
It would be k to the 0, but we got to remember a rule.
0, don't put it.
K to the 0 is something special.
What?
Dope boy.
So this is going to be k to the negative 7 plus 7, which would equal k to the 0th. But anything to the 0th power is 1. That's one of the rules that we need to know. So when we're dealing with these exponents, we better know those two big rules. If it's negative, we flip it and put it on the bottom. If it is 0, we have a 1. Okay, let's keep pushing through. Do you notice how we have 3 A's this time? I'm multiplying a 3 times. Remember, if I have a to the nothing, that's actually to the first. We can combine all 3 of those into just being a to the 1 plus 3 minus 9. So we can do 3 of them. We don't have to just do 2 of them. We can do 3 of them. I have a to the 1 plus 3, which is 4, minus 9, which would be a negative 5. But yes, if you wrote a to the negative 5, you'd have it incorrect, because it says specifically you can't have negative exponents. What do we do to make it positive again?
Well, 1 over a to the power of 5.
1 over a to the power of 5. Yeah, we'll have 1 over a to the 5th. Okay, but now we have something slightly different. When I multiply x times y, it doesn't do anything. It has to have the same base to adding our powers. So what we need to do is we need to realize that, well, if I have a chain of multiplications, I can change the order they come in. I can actually rewrite this as just y times x to the 4th times x to the negative 1. I'm just rearranging that multiplication. It's kind of like 2 times 3 is the same thing as 3 times 2. I'm putting things together I can actually multiply. You cannot multiply x times y. It's not going to change. It has to have the same base. It would be x cubed. So we can rewrite this as y times x cubed. Or you may have written it as x cubed times y. Yeah. We did. What's 4 plus a negative 1? It's basically 4 minus 1, right? Which will give us 3. So it's not we just look at a number and increase it. We have to look if it's positives or negatives. So 4 minus 1 will get me this 3. My y doesn't have anything to pair with, so it just stays alone. Let's keep moving along. Now, when we multiply, we must have the same base. So do you see how we have 2 s's here? And we have the 2 r's? So we're going to put those things together. I'm going to put my r minus 2 times my r to the negative 4.
Add that together and have it be r6.
R to the negative 6.
Oh, yeah.
Yep.
And then you put 1 over r and then the 6 like that?
Yep, we're going to do that. So we have r to the negative 6. And what happens if I have s times s? S squared, or s to the 2. Because remember, this is actually s to the first, s to the first. 1 plus 1 is 2, so that's times s squared. Why do I have this problem wrong so far? Because I have a negative exponent, so I need to turn that into a 1 over r to the 6th. Or we might be able to realize that it's just s squared over r to the 6th, because the negative sends it to the bottom. The negative sends it underneath that s squared because it is 1 over r to the 6th. This stuff is really difficult if you don't practice it, though. We have a lot of rules that we have to follow, and that takes practice. So those of us that aren't doing homework, it shows up on our quizzes, and it's going to show up with your understanding of this stuff, because it's going to get more and more difficult as you go if we don't practice this stuff. We have to practice. So I'm going to keep going to some more complicated problems. We probably don't have time to do all of them, but we'll give a shot at how many we have. Now, we're going to simplify the variables with the product rule. Now, for multiplication, this is a chain of multiplication. We're going to put together things that I can actually multiply. Can you multiply 4 times 2? Yeah. So what we're going to do is we're going to reorganize this and put the 4 times 2 together. And then we'll put the a to the 7th times the a cubed, because this is all multiplication. I know it feels like these are linked by something else. There is a multiplication sign that's hiding right between these things. So we just need to focus on the things I can actually multiply. So I can multiply the 4 times 2. If you don't need to move it, it's fine. You just have to realize I can do that 4 times 2, giving me 8. Yeah.
Would it be 8, 10?
It'd be 8a to the 10th power, because that 7 plus 3 gives me that 10. That's perfect.
How do you do like 36?
How do we do 36? Let's take a look at 36. We'll bounce around. 36 looked pretty difficult, right? You need to realize all of the stuff you can actually multiply. First of all, the one hard thing about 36 is, do you see this negative sign out here? Do you see how everything's a chain of multiplication?
Yeah.
So that negative sign is going to stay out front. There's nothing for, if there was another negative sign, negative times negative would be a positive. But we're going to keep that negative sign out front. And then what we're going to do is we're going to kind of combine all of the terms that we can multiply together. So you see that 4 and that 7? Can we multiply a 4 and a 7? Okay, let's put it in order. So we can do the 4 times the 7. We can multiply all of the a's. Now remember, I took that negative sign and basically moved it out front. We're not worried about the negative sign right now.
Does that affect is that not negative for?
Yeah, the negative will just stay out front. The only time we're worried about a negative changing is if there was another negative and I have a negative times a negative to make it positive. Okay, so think of that negative as just staying out front, not worried about it. All right, we have an a to the first. Do you see this a to the first? Mm-hmm. And we also have an a to the 8th. And we also have another a to the first. So we have an a to the first times that a to the 8th times that a. And we have a b times a b squared times a b to the 6. I'm basically just pulling down everything I can actually multiply and putting them together. Do you have an answer, or you have a question? Okay, hold on a second.
28.
No, hey, hold on a second. I'd like us all to just try to finish this one. Now that I have it all organized, try to finish it. We make a very difficult looking problem look a lot easier if we organize it like this. Try to simplify this.
I think I got it.
Awesome. If you can do this problem, you can pretty much do any problem.
I just get confused with how sometimes the negative signs. I don't know if I'm supposed to subtract or add. So then
I gotcha. So in multiplication, remember multiplication, you don't add or subtract negative signs. It's just a negative times a negative makes a positive. When they're part of our exponents, remember we're just going straight across and just going 8, -1, a -3. You're just stacking on. So it either goes in the positive direction or it goes in the negative direction. Did you get it? Oh, I can't see. Oh, here.
I don't get it.
Well, we just need to add our exponents.
Let me see it.
Don't overthink it. Gabby, you doing okay? Did we finish it? Nope. Not going to give it a shot.
Yeah, okay.
Okay. Yep.
Is it negative? Oh no, we got a to the power of b to the power of 9.
Yeah.
Oh, guys.
Miss Cox isn't here today.
I know.
Holy cow, stop. I'm just getting a Band-Aid. Doesn't mean the class devolves into chaos because I turned around. Okay, if you didn't get this one, don't overthink this process. Can we do 4 times 7?
Yeah.
Yes. And in this case, it'd be a -28.
Yes, guys.
Now, when we multiply these, we are just adding the exponents up. All I'm asking you to do is 1 plus 8 plus 1. 10. Times a to the 10th times, and b to the first, second, sixth. That's 1 plus 2 plus 6, which is 9.
I got it right, but I added up the exponent.
Now, I feel like a lot of us that didn't even try this aren't actually trying anything. Do not just sit there and do nothing. Don't just absorb what I write down. You want to think of like that next step. Let's take a step back and look at 35. 35. Now, how many negative signs do we have in there? 1.
Leave it out.
We're going to move it to the front. We just got to see if that negative is going to cancel out with another negative. It's not going to, so we're going to bring that negative out front. It's just a chain of multiplication. A negative 2 times 3 is the same thing as 3 times a negative 2. So we're going to go ahead and we're going to bring that negative sign out front because we don't have anything else to cancel it out with. So we're going to have a negative. What can that 7 be paired with in that expression? The 2, okay. So we have 7 times 2. So we could probably do that. I have a c cubed. What other c's do I have?
C3.
I have a c3. What's in between that before we miss it?
TCD.
We have a cd, so that's c to the first, right? And we have a c cubed. I'll put some multiplication signs between that. Do I have any more c's to add to that?
No.
No. So now we move on to our d's. What d's do I have? I see I have a d squared. What other one do I have? Yeah.
You have a D
I got my answer.
to the 8th power.
I have a d and I have a d to the 8th power.
The first, yeah, then you got 11, D to the 11.
Yeah, what do you got?
Negative 14 and c to the power of 7 and d to the power of 11.
Power of 11 is correct.
I might need tutoring for stream.
Math.
All you need to do when you are multiplying is put the things with the same bases. The 7 times 2 is 14. We have a c cubed, a c to the first, a c cubed. What's 3 plus 1 plus 3? That's where we got the 7 from. When we stack our d's, we have a d squared, a d to the first, a d to the 8th. What's 2 plus 1 plus 8? 11.
Oh, wait.
If you know the rule, it's just adding. Yeah.
Can we do 38?
Yeah, we'll do 38. Okay, I was told we're going to do number 38. So can you guys help me out real quick? Do we have, how many negative signs do we have?
1.
But is this attached by multiplication?
No. So
No. Do you see a multiplication sign in here? It says minus. So that means we need to treat these as two individual things that are trapped with the negative sign between them. Notice every other problem was all attached by multiplication. This is attached by subtraction. So we're going to do these as individual things. What two numbers can I multiply to start off this one?
9 times 2.
9 times 2. I don't need an answer. I just need 9 times 2. I have some m's, right?
Yes.
I have m to the 6th, and what other m do I have?
M to the 4.
M to the first, isn't it?
Yeah.
Yeah. And then I have an n to the 4th. Do I have anything to match up with the n to the 4th? No. Now let's go to the other expression. And don't forget about your negative sign. What two numbers can I multiply there?
4, 3.
I have a 4 times a 3. I have an m squared and a m to the what?
3.
M to the 5.
My fault.
Then we have an n cubed.
What about the M to the 2? Oh, you did that.
We already did that. And then we have an n to the first. Hold on a second, because I think you have the answer, right?
So do we do 18 minus 12?
No. No.
Yeah, bro.
No, he's asking the next step. He didn't actually give an answer. He just asked the next step. We'll figure it out if we can in just a second, okay? We have to simplify first. Remember, we always do our multiplication and stuff first, right?
I did by multiple.
Multiplications, exponents, stuff first. And once we get to there, then we'll take a peek at it. All right. With me now. What's 9 times 2? 18. Now, the next part is you just knowing a rule. Because can you guys do 6 plus 1?
Yeah, 7.
So it's 7. So we have m to the 7th. N to the 4th has nothing to work with. Then we have minus, can we do 4 times 3?
Why did we change it to 4 times 2? Oh, yeah, 12.
12. I didn't change it. We wrote down that 4 and the 3, right? Then we have m squared, m to the 5th. And that's it, right? What's m squared times m to the 5th?
7.
M to the 7th.
So would the final answer be 18 times?
Hang on. Let me finish this. N cubed times n to the 1st is n to the 4th. All right, now we're combining what we did on the other side. When you add or subtract, you must have like terms. M to the 7th, n to the 4th. Does that match our m to the 7th, n to the 4th?
Yes.
Aren't those the exact same?
Yes.
Are they like terms?
Yes.
So then we can subtract them. So as long as these match. So let's pretend this said n to the 3rd. Would they match then? If this was m to the 7th, n to the 4th, m to the 7th, n to the 3rd, would those be like terms?
No.
And then we couldn't do anything else. So when you get to this stage, you just have to ask yourself, are there like terms to combine? If they are, combine them. So we have 18 minus 12, which is 6m to the 7th, n to the 4th. So yes, we can actually do that subtraction. But I couldn't answer that question until we were here, okay? Because I wanted all of us to be on the same page that they had to be like terms to do that subtraction.
So we're not going to combine the two exponents?
We can't combine the two exponents. You can't add this and say I have mn to the 11th. It only works if it's the same base.
34.
Sure.
34.
We'll do 34. Remember, these are the hardest ones, right? These are the hardest ones.
Are these going to be the hardest of the chapter?
We have some division we have to handle, too. Well, no. Hang on. Division is just subtraction. Multiplication is addition. Division is going to be subtraction. Okay, so we're going to do number 34. Okay, so we have a negative out front. We have a 12. That's going to go with the number 1/3. Okay, I have p to the 8th. What's p to the 8th going to be paired with?
P 3rd.
P to the 3rd. And then we have q to the negative 2. What does q to the negative 2 pair with?
Q to the Q squared.
Q squared.
Why did you write an 8?
Mr. Payne.
Because it says p to the 8th. Why wouldn't I write an 8? I got to write what they wrote.
Oh, no, he's talking about after the P. Yeah, after the P, you just wrote an 8.
P to the 8th. And then p to the 3rd. I'm confused at what 8 I wrote. That's.
You wrote 2, you wrote 8 to the...
Oh, that's q to the negative 2. Q to the negative 2. Q
Looks like an 8.
squared.
Wait, would that just be 0?
Oh, hang on. Okay, so we got these. Now remember, 12 times 1/3. That's actually 12 over 1 times 1/3. That's really 12 over 3, which is negative 4. P to the 8th times p cubed. Remember, this is just 8 plus 3. We should have p to the 11th. And then we have q to the negative 2 plus 2. What's negative 2 plus 2? 0. They're opposites. So we have q to the 0th, which isn't correct. We should write this as negative 4 p to the 11th. And that's it. Because q to the 0th is just 1. We no longer have the q. It just turns to 1. Anything to the 0th is just 1.
Then what do we do with the 1? Just add it on to the...
We do nothing. I mean, there's technically a hidden 1 out here, but we don't write hidden 1s. Because what's 1 times anything? Itself. So if you have a 1 in the chain, you can write it. Like, there wouldn't be anything wrong if you wrote times 1. But it's just easier if we cancel out that times 1. Like a lot of times we don't write 1x, we don't write 1y, we just write x and y. All right, questions?